Welcome back to the channel, Bridging the Gap, Student to Engineer, where STEM professionals provide advice to students. This video is a discipline deep dive into electrical engineering. This was a request, so if you are looking for any deep dives into disciplines or into various schools, or if you just have general questions, please leave a comment and we will get back to you. We're working on a lot of videos right now over the holidays with a little bit of break from everything else. So let's get to electrical engineering. Okay, so electrical engineers, like all engineers, identify, formulate, and solve complex engineering problems. They do that by applying principles of engineering, science, and math to design, develop, and test electrical and electronic equipment, components, and systems. They also research, design, and improve equipment and processes for manufacturing products, most often related to either manufacturing electrical related products or the electrical parts of the equipment and the processes for manufacturing of anything. They also apply their electrical expertise to a wide range of problems in a wide range of areas, including robotics, aerospace, navigation, communications, building systems, automotive construction, power generation, and manufacturing. So lots and lots of different areas. Electricals are essential to the world. If you think about anything that has electricity running through it or relies on electricity, there's got to be some sort of electrical engineer involved in the design and development of that thing. That is everything from generating power to transmitting that power to our homes or to our businesses, all the way down to the very, very small uses of electricity in a circuit board. So there's a wide variety of applications for electrical engineering, and therefore electrical engineers as a group are one of the largest groups of engineers out there. It is one of the basic engineering disciplines that can be applied to a lot of different things. Pre-computers being really big, electrical engineers really focused on power generation, power transmission, and those kind of like macro applications of electrical. And then there was a big boom for computers, and it was there was a big shift in programs related to electrical engineering focusing on computers and the smaller micro electrical. And so there are a number of programs out there that are called electrical and computer engineering, but a lot of schools have kept those separate, and some schools have what they even call power engineering or energy engineering to differentiate that from some of the micro electrical. So we'll get into a little bit more about that as we go along here, but there is a big application and a lot of specialties within schools on how they teach electrical and what they focus on. Okay, so if we look at the career outlook per the U.S. Department of Labor Statistics, the 2024 median pay was $118,000, which is a very healthy number. Like all engineering disciplines, the typical entry-level education is a bachelor's degree. And the number of jobs in 2024 is almost 300,000 with a job outlook of 7%. And looking at by the end of the 10-year period ending in 2034, there being about an additional 20,000 or around 300,000 total in the US. So it's a pretty big area. And like I said, lots of applications, growth much faster than average. And so we will be seeing more electricals being hired in the coming years. Okay, so industry organizations, this is very important for any discipline, not only for your professional growth, but also as a student getting information about the industry, going to conferences, getting connected to professionals, finding out about scholarships, being involved in student competitions, All of those things are really important. So I suggest that any student go out and find out about the industry organizations. Typically, they will have student fees are very, very low. Sometimes they'll let you in free to their conferences. Sometimes they'll make you pay just a very small amount compared to what professionals pay. But as far as electrical engineers specifically, IEEE, or the Institute of Electrical and Electronic Engineers, is the main organization. They have a lot of subcommittees for specialties. But in addition to that, there's a number of different organizations that we've listed here. All good things to go check out. And as I've said on other videos, if something is even mildly interesting to you, I would suggest going and checking out, see if they have any scholarships or anything where that organization is interested in talking to students, or has a local chapter meeting or something that you can attend. Great way to get a job, great way to meet people. So just these organizations, Association for Computing Machinery, there's several here about power, power generation. There's Audio Engineering Society. So again, we're going from the large macro power engineering to smaller audio engineering. Optics and photonics, even smaller. And then Electrical Power Research Institute, EPRI, does a lot of research in the electrical area and provides standards and those types of things, but is also just good for students to look into and understand what that is. Okay, so schools. There are over 370 ABET accredited programs. I've listed some here. I'm not going to list all 370, but I will provide the link to ABET so you can see what the ABET accredited programs are out there. But similar to mechanical, you can go to almost any school that has engineering and major in electrical engineering. You do want to look a little bit closely at what kind of electrical engineering it is, if it's electrical and computer, if they're just focusing on computers, or if they're going to give you the option to do more macro engineering. But generally, you can pretty much go to your local university or a highly ranked university, or a lot of different types of opportunities for you if you want to do electrical. Okay, so just like all of the other discipline deep dives, I'm providing outcomes from various schools. These, again, are not necessarily schools that we recommend, but they are schools that provide the data that we're looking for at the major level, and so that we can compare. So just to start with, the schools that are listed here are mostly public universities. Rose-Hulman Institute of Technology is a private engineering focused school in Indiana, but the rest of these are public. But you can see the electrical classes, they tend to be much smaller than, say, mechanical, where typically you're in like 20% of the entire engineering student body. These are ranging from a very, very small 2% at Virginia Tech to as high as 10% at Colorado State, 12% at UIUC. So not huge. You're not going to typically be surrounded by a lot of people with the same major, except for maybe if you're going to Illinois. But still a good major to have. If we look at the positive student outcomes in the fourth column here, there is quite a range. So definitely not a major where you can just go anywhere and be assured that you're going to have a great student outcome. No, so these range from 74% up to 100%. I will tell you that the Purdue 84% number was significantly higher on the previous year. So this is 2024 data. The 2023 data and before for Purdue was all in the high 90s. So I don't know what's happened there, but these numbers do fluctuate. Virginia Tech, if you are in Virginia, I would look closely at that school before just assuming that you can go to any school and have similar outcomes, because their outcomes for electrical are not that great. But pretty good overall. Mostly in the high 80s, 90s range for electrical. So one thing I'll just tell you about electrical is I've worked a lot of different places. We always have trouble getting electricals. But I have worked in construction and construction management, larger infrastructure type places. I haven't worked in much in manufacturing. But when we look for electricals, and what we always have a hard time finding is electricals that are interested in power, power transmission, power generation, um, the construction and inspection of electrical systems within buildings, and similar types of things. We don't find a lot of electricals who are interested in that. They're more interested in computers. So if you are interested in the infrastructure side of engineering, of electrical engineering, you may have better outcomes than some of what we're seeing in these places. But along those lines, if you go to a school that's electrical and computer engineering, and you are interested in macro electrical, you need to be specific about taking those classes like power transmission, power generation, when they're available to you, and make sure that you are communicating that that's what you're interested in when you're looking for internships and full-time employment. Okay, so let's go to the grads employed and the grads going to continue their education. A huge variety here from Purdue and UIUC having pretty low percents grad employed. UIUC actually has a higher percent grads going to grad school than they do to employment. That actually is pretty typical for that university. So something to think about if you are considering UIUC. A lot of their engineering grads go on to grad school. So if that's something you want to do, then that's a good place to do that. If that's something you don't want to do, then you can always go get another job. In contrast to that, Virginia Tech having only 4% of their grads going on to grad school, that is an amazingly low number. I know that their student body is a little bit smaller, but the Virginia Tech numbers being so low to grad school is interesting to me. Something that you should look out for if you're considering that school. So overall, though, not a huge percent of electrical engineering majors go on to grad school. That's always an option in engineering, but if you're looking for a discipline where you can get your bachelor's, get out and go get a job with pretty good certainty, electrical is definitely a good option for you. Okay, so first employers, these company names are directly from university websites with student outcomes where they talk about who hires from them. So real companies, real electrical engineers going to work for them. Very similar to what we saw in mechanical. There's a lot of grads that are going into motor companies, and then a lot of grads going into aerospace, a lot of grads going into space and defense. So that first column is really just about automobiles, spaceships, and defense type companies. But then on the other side, we've got power transmission, power generation type of companies. And then we get into consumer products. A lot of consumer products need electrical. Anything that you have that has any electricity running through it is going to have an electrical engineering major associated with it, like I said. So we've got some more utilitarian, but then GE appliances, Caterpillar making construction equipment, and then Bechtel and Burns and McDonnell both being engineering, procurement, and construction companies that definitely need electricals to do design work and field work for construction. Okay, so first job titles, again, just like the other list, this is from actual university lists. So electrical engineer, that makes sense. Systems engineer, distribution and substation control systems engineer, more substation product analyst. So if you want to do products, if you want to do larger transmission type things, it's all available to you. Project engineering and field engineering and manufacturing, all different roles you can have within engineering. So project engineering would be where you're doing more project management, or you're in charge of a project from the design standpoint, and you are controlling the scope that's designed or assigned to engineers, and working through that, managing the cost, the schedule, and those types of things. A field engineer is where you're going to be at a construction site, ensuring that the electrical subcontractors are doing what they need to be doing, that they're installing what is on the design, and solving any design issues that come up in the field. And then a manufacturing engineer, you're going to be in a manufacturing plant, doing something similar where you have designs for what is being manufactured, and you're making sure that they're being manufactured to specifications. I haven't talked a lot about controls engineer, although I did mention it, control systems. So one subset of electrical engineering is control systems, and that is basically an electronic system that controls something. So it might be manufacturing, it might be building HVAC system, those types of things. A big use for electricity in today's society is controlling things, and so there's a big need for instrumentation and control engineers, which is a subset of electrical engineering. So definitely a good thing to look into, and if you are interested in that at all, also a good thing with a good prospects. Okay, so for resources, we've got Engineering Expectations. This is a small company that is focused on helping high school students that are looking at engineering. They have a website, they have a workbook that's available, so definitely look them up if you are interested. I also have the link in the description of this video. And then IEEE has what they call a pre-university STEM community with a program called Try Engineering. So while that program is broad across all engineering disciplines, it is from IEEE. So something to check out if you are interested in electrical engineering. And while you're there, look at IEEE as a professional organization and see what they might have available to you. All right, so that is everything on electrical engineering. If you have any questions, please leave a comment. If you've got requests for other disciplines for us to look at, please also leave a comment. We'll get back to you. Otherwise, we will see you on the next one.